Hello class! Today we are going to be talking about special triangles. So previously we've already covered some content about properties of triangles, how to draw triangles, and looking at different components of triangles such as sides, angles, and how they're congruent, different ratios with similar triangles. So today we are going to be looking at special triangles, special right triangles. This is going to lead us into a whole unit about right triangles. But we're going to start off kind of simple with these triangles that have some special rules. So after today, I will be able to explain the relationship between 30, 60, 90 triangles. So the relationship, this will include being able to explain the ratios and how to find different side lengths of a 30, 60, 90 triangle. Okay, so we have two special triangles. We have the 45, 45, 90 triangle and the 30, 60, 90 triangle. So today you don't have to worry about knowing exactly what a 45, 45, 90 triangle is, but I just wanted to introduce it to you so you know what the second triangle is that we're going to be looking at. So 45, 45, you'll notice has two congruent angles as well as two congruent sides. Whereas the 30, 60, 90 triangle doesn't have any congruent sides or any congruent angles. But that's the one we're going to be focusing on today. Here is a picture that shows you what the ratios are for the 30, 60, 90 triangle. So let's break this down a little bit. You'll notice that the base is equal to n. So our side length for our base is n. I also want to notice that the side length with n is across from the 30-degree angle. That'll be really important as you start to draw your own pictures. So take note of that in your notebook. Make sure you guys are taking notes on what this looks like. That's going to help you out for the rest of the lesson. Okay, so across from that is our hypotenuse. Over here is our hypotenuse. Let's remember our hypotenuse is the longest side on a triangle. It also, in this case, for right triangles, is going to be across from the right angle. And in our 30, 60, 90 triangle, the hypotenuse is actually 2 times the n value. So twice the length of the base down here. Our other side is across from the 60-degree angle. That's going to be n times the square root of 3. So these are our ratios. They're written in word form if you prefer to look at the words instead of the pictures. Okay. So let's dive into a couple examples of this. For all of these problems, you're going to want to start by drawing a picture. Okay, we're looking for the length of the hypotenuse. Let's think again. What's the length? What is the hypotenuse? Which side is the hypotenuse? Yeah, it's going to be this long side over here. We have two other side lengths, 4 inches and 4 square root 3 inches. So where should I put the base at? Note that your triangle doesn't have to look perfect. It doesn't have to be a 30, 60, 90 triangle exactly. You just have to have an idea so that you can be able to sketch it out and use it to find the rest of your ratios. So which side will the base go on? Which side will be the n? Let's look back at our ratios. The n is across from the 30-degree angle. So our n in this case is going to be 4 n square root 3 or 4 square root 3. Okay, we already talked about this is the hypotenuse over here. And what is our n value? Yes, we said earlier our n value is this base number over here, which is 4 in this case. So how are we going to find our hypotenuse? Look back at your notes. Look back at your ratios. What is the hypotenuse equal to? Yeah, it's equal to n times 2, or 4 times 2, which will just be 8. So now we have a perfect 30, 60, 90 triangle with all of our sides labeled beautifully. Okay, we have a random 20 here. That's just going to be our hypotenuse. So for this picture, I just drew my right triangle differently so you guys can get used to the fact that your triangles don't always have to look like this. They can be upside down on their sides. It's important, though, that you get your angles in the correct spots. So we have our right angle. That's going to be where our hypotenuse is. 30-degree angle is going to be across from the base, and 60-degree angle is across from this other side. Okay, so in this problem it says find the length of the two other sides of a right triangle if the length of a hypotenuse, which we have here, is 20. One of the angles is 30. If one of the angles is 30, we're able to find the other angle is 60. Remember that the sum of the angles in a triangle is 180. We all should be used to finding those right now. So if you would do 180 minus 90 minus 30, that would just give you 60. That's where I got this from, this number here. Okay, so we have a 30, 60, 90 triangle. We want to find the length of the two other sides, x and y. How can we find our n value from these numbers? How can we find our n value? So our hypotenuse, we know, would be 20 equals 2 times n. So our hypotenuse is always 2 times n. So if our hypotenuse is 20, we can find n by doing 20 divided by 2. So just solving for n. That would give us n equals 10. If we look back at our ratios, we remember that the base across from 30 is going to be the n value. Okay, that was pretty easy. What about our y side? If n equals 10, and we know that the side across from 60 is n times the square root of 3, our y side is just going to be 10 times the square root of 3. Okay, good job. Now, on your own, I want you to try to make your own 30, 60, 90 triangle problem. So try to experiment with doing something like this, picking different side lengths. In class, we are going to share these out and have our partners try to solve the problems that you created. Just make sure you submit these problems to me before class tomorrow. Okay, thank you.